Welcome back. In today's session, we are going to discuss a very important concept, that is plant layout. Plant layout is one of the important concepts in the manufacturing management or productions management. It basically refers to the disposition of the facilities and the services of the plant within the area of the site selected previously. That means it basically refers to determination of space required by various facilities and services of the plant so as to have smooth manufacturing process with minimum overall cost. Now here by facilities I mean the equipment and the machineries, and by services I mean the services of the plant like cafeteria, washroom, then your lunchroom, tool room, general office, dispensary. So all this forms the services of the plant. So how to arrange all these services of the plant as well as the facilities, that is machineries and equipment, within the area of the site selected is nothing but plant layout. This plant layout basically refers to putting the right machine at the right place so as to permit the processing of the product in the most effective manner through shortest possible time as well as shortest possible distance. So in today's class we are going to see what are the objectives of plant layout, that means what are the characteristics of a good layout, and then we will see what are the different types of layout. So let's go into the deep. As we have discussed what is meant by plant layout, it means the disposition of various facilities and services of the plant within the area of the site selected previously. And so it involves determination of space requirement for the facilities and arranging them in a manner that ensures steady flow of production with minimum overall cost. Coming back to objectives of plant layout, as I have told you, the basic objectives of plant layout is to keep the right machine at the right place so that the processing of the product can be done in a most effective manner through shortest possible distance and shortest possible time. So it basically refers to minimize the movement of the material as well as the machines, as well as the operators within the between the operations. I repeat, a good plant layout ensures the minimization of movement of materials as well as operators between two operations. So by doing so, it facilitates smooth manufacturing process and reduce manufacturing cycle time. And also it minimizes the material handling. One of the characteristics of a good layout is the efficient utilization of space. By space here I mean both the vertical as well as the horizontal space. In many factories you will find that the items, non-perishable, especially items, are stacked one over another and thereby utilizing the vertical space. So one of the objective of good plant layout is not only to utilize the horizontal space but also to utilize the vertical space. Now a good layout also ensures that main material machines are readily observable at all times. Very important point, that a good layout ensures that to make the material machine and operators readily observable at all times and thereby helping in or ensuring in easy supervision and better production control. Another important use of materials plant layout is to make the servicing and maintenance points readily accessible so that the machines can be maintained or machines can be taken for maintenance readily and maintenance job can be done easily. So these are basically the objectives of plant layout. Now coming back to the types of layout. Types of layout. Depending upon how the machines or the equipments are arranged, we have got different types of layout. We start with product layout. Product layout is also called layout by sequence because all the machines and the equipments which are required for processing or for manufacturing a product are kept in a sequence. So this layout is also called layout by sequence. Here the materials flow unidirectional towards the stage of completion. So inputs flow from one side, it passes through each of the equipment and the machines, and then output come out from the other side of the manufacturing facility. Now in this case, what happens, since all the machines are dedicated for producing only one product or one kind of product, so this type of layout is basically suitable for mass production where we produce a large quantity of a single standardized product. So this product layout basically it is used for mass production where products have reasonably stable demand, and it is used for standardized products and not customized products where products are produced in bulk and they are stored with the assumption that there will be demand for that product in the market. So that is product layout. So how a product layout looks like, it looks like this. Inputs are coming from one side, it is passing through all the machines, or it may skip one machine or two machine in between, and then coming out from a product coming from the other side. Now a dedicated line can handle only one product or maybe two or three, but this is a dedicated line, and since it is a dedicated line, so we need high capital investments, right? So here the machines are put in a sequence and input are coming from one side and the outputs are coming from the other side. So all the machines needed to produce a product are put in a sequence in case of product layout. Now let's see the characteristics of product layout. The first is it involves high capital investment. Why high capital investment? Because we need more number of dedicated machines and high cost of special purpose machines are required, and each of these dedicated machines are used to produce a particular product line, right? So the machine which is used for particular product line, suppose A, cannot be used to produce another product B. Since it's a dedicated line, if that particular dedicated line can be used only to produce product A. Since these are completely dedicated lines, so one of the characteristics of product layout is it has got less flexibility. And in product layout, we are producing standardized product where all the machines are kept in sequence. So the workers, they have to work or operate on their particular work center in the particular work center, and so they are low skilled workforce, right? So each worker is working on a particular work center and he has got skill for working in that particular center, and so it's low skilled workforce is required for such layout. Now as we have seen that it is a case of standardized, it is suitable for standardized product, and it involves mass production. So volume of production is high, but the product variety is low. So number of products which can be produced in a dedicated line is very few, one or two, but the amount of product or production volume is very high, right? Since we are making standardized products, so production volume is very high. But the biggest disadvantage of this product layout is that if there is a breakdown of a machine, then it will jeopardize the whole production line. So breakdown of a machine completely stops the production. So this is what a product layout means. Okay. Next is process layout. A process layout is called layout by function. Why it is called layout by function? Because all the machines of similar type are grouped together and put in the same place, right? So here, as we can see from the diagram, that all the machines, suppose all the lathe machines represented by 1 are put together, all the drill machines represented by 2 are put together, like on. This goes on, like this goes on. So this is suitable for machines. Here the suitable similar machines are grouped together, and this is suitable for batch production where we produce in small batches. So as you can see, the inputs will move from one machine to another machine, but the machines are put in groups. So it will move from one machine type to another machine type. And here we need skilled workers because they have to decide which routing the product should follow in order to get processed. Right? So what are the characteristics of product layout? Let's see. Since all the general purpose machines are put together and they're put together, so it involves low capital investment. So if by any chance if one machine is not working, it can be another machine can take its place and we can process our product in other machines. So it is not a dedicated line, unlike product layout, which is a dedicated line where each of the machines are dedicated for producing a particular product. And so it was a high capital investment. But in case of process layout, this should be, I have written here product, this should be process layout. In case of process layout, it involves low capital investment because we are not dealing with special purpose machine, as well as the low capital investment is involved because machines are not dedicated. So since machines are not dedicated, and it helps in greater flexibility. Here the workers have to take the decision which route is to be followed in order to produce different products, so it's high skilled workforce is required. As we have seen that it is suitable for batch production, so volume of production is low but variety of production is high. And one of the biggest advantage of process layout is that if any of the machine fails, it doesn't stop production because other machines of the same group can take its place and there will be smooth flow of production even when the one machine fails. So this is what a process layout looks like. All the machines are grouped together and it is the worker who decides through which routing the product has to pass through so that different products are produced. So it involves high skilled worker. Next is fixed position layout. This fixed position layout, it is applicable for project types of industries such as manufacturers of aeroplanes, ships, large turbines, pressure vessels which involve heavy materials and sub-assemblies. And this type of layout is suitable when assembly consists of a large number of heavy parts, the transportation cost of which is very high. So what is being done in fixed position layout, all the materials, man, components and sub-components or other input resources are brought to the project site for the completion of the job. So instead of producing the product in the factory and thereby transporting it, which is not possible because of the huge size of the product, all the resources which are needed to manufacture the product are brought at the site of the project. So this is called, since the position of the place where the product is to be finally delivered is fixed, this is called fixed position layout. Okay. Fourth is mixed or combined layout. So as the name suggests, we can understand that it is a combination of product and process layout, and it is used when the company's product contains a lot of components or parts and product is required to be produced in different types and sizes. Since products are required to be produced in different types and sizes, we are talking about batch production of the final assembly. But each assembly contains a lot of components and parts, and which are manufactured through product layout and which are produced in bulk. So the components or parts are produced in bulk. They are standardized products, standardized items, so they are produced through product layout, but the final assembly is produced in small batches, and hence they follow the process layout. Next is the cellular layout. Here the machines are grouped into cells, and the cells functions somewhat like a product layout within a large shop. Cellular manufacturing, which is actually an application of group technology, has been described as a stepping stone to achieve world-class manufacturing status. What is a cell? A cell is a cluster of carefully selected sets of machines, but set of functionally dissimilar machines to close proximity to each other. The result is small standalone manufacturing units dedicated to the production of a family of like parts. Mind it, a cell is used to manufacture a production of a family of like parts, right? All parts basically follow the same routing with some minor variations. Example, you may skip one operation or two in between, but generally it follows the same routing. Now, a cell has got high operational autonomy. What do we mean by this? All necessary machines and manpower are contained within the cell, thus giving it a degree of operational autonomy. Moreover, each worker is expected to have mastered a full range of operating skills required by his or her cell. So that means each worker knows how to operate each machine within the same cell. And so, through job rotation and training, these are the two necessary conditions for effective cell development. So here we see that in cellular layout, the machines are grouped together to form cells, as we have seen here. Just see, in case of process layout, what happens? All the machines which are of similar type, they are grouped together, right? Machine 1 are grouped together, machine 2 are grouped together. But in case of cellular layout, the machines which are needed to process a product family are grouped together to form a cell. Now, each cell has got operational autonomy because it has all the machines and equipment necessary to carry out a product family, to produce a product family, as well as the workers. It can gain operational autonomy through job rotation and training to the operators within the same cell. Advantage of cellular layout is that the world-class manufacturing status is based on cellular layout, which allows the cells to produce in small batches, and also taking the advantage of the product layout of the continuous flow line. The cell design provides for quick and efficient flow and high productivity associated with assembly lines. As we know, in product layouts is associated with high productivity. However, it also provides the flexibility of job shop, allowing both similar and diverse products to be added to the line without slowing the process. This is very, very important because of the cellular design. It allows similar as well as diverse products to be produced to the line without slowing the process. Okay, so each cell is designed to produce one type of product family, so we can add different products, or diversity of the products can be increased by introducing more cells, as well as the advantage of product layout can also be maintained. With this, we come to an end of today's session. In today's class, we have seen what is meant by plant layout, what are the characteristics of a good layout, and finally we have seen what are the types of layout. We started with product layout, process layout, fixed position layout, then combined layout, and finally cellular layout. Okay, So I would request you once again to stay back at home and fight against pandemic COVID-19. Till then, see you, bye, and take care.